February 20th, 1943, north of Kasserine Pass, Tunisia. The battle report would never fully capture what the German tank commanders witnessed that morning, what they saw but couldn't explain, what they experienced but couldn't comprehend. American Sherman tanks executing maneuvers that defied everything Wehrmacht doctrine said was possible without visual signals, without dispatch riders, without flags or flares cutting through the smoke. Through the dust and smoke of the North African battlefield, 5 Sherman tanks, separated by broken terrain with no line of sight between them, converged on German positions with timing that seemed supernatural. No flags waving between turrets, no flares arcing across the sky to signal movements, no dispatch riders racing between vehicles on motorcycles. Yet they moved as a single organism, each tank covering blind spots the others couldn't see. Each crew knowing exactly where their comrades were positioned, what threats they faced, where support was needed. In German Panzer IVs, equipped with Fug 5 radios, tank commanders struggled to hear their own company leaders through static that overwhelmed their amplitude modulation systems. The 10-watt German transmitters state-of-the-art by 1932 standards. Cutting edge when first deployed, couldn't penetrate more than a few hundred meters when tanks were moving, engines running, tracks grinding across rough terrain. Most German tanks carried only receivers, unable to report what they saw, unable to call for help, unable to warn comrades of danger. They could listen but not speak, hear orders but not respond electronic spectators to their own battles. The Americans were operating with technology the Germans didn't know existed, didn't understand, couldn't imagine. Frequency modulation radios in every single tank, not just command vehicles, not just platoon leaders, but every tank. Crystal-controlled precision that held frequencies stable despite vibration and temperature. 25 watts of transmission power that cut through battlefield chaos. And clarity, crystal-clear voice communication that penetrated engine noise and artillery thunder like a knife through paper. 8,000 miles from Detroit's assembly lines, the most decisive technological advantage of World War II was revealing itself. Not in armor thickness, measured in millimeters, not in gun caliber or muzzle velocity, but in the invisible electromagnetic waves that connected every American tank crew in ways the Wehrmacht never imagined possible. The transformation began on July 22, 1941, when the United States Army standardized the Signal Corps radio sets SCR-508, SCR-528, and SCR-538 for all medium tanks. While German forces were advancing through the Soviet Union using tactics that depended on radio communication between command vehicles, Guderian's Blitzkrieg doctrine made real American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology that would render German systems obsolete before most German tankers even knew they were obsolete. The engineering team included Daniel E. Noble, who conceived the application of FM technology in military vehicles, bringing civilian broadcast innovation to battlefield communications. Henryk Magnuski, the principal RF engineer, solved the brutal technical challenges of installing sophisticated electronics in the harsh environment of a tank vibration that could shake components loose, temperature extremes from desert heat to Russian cold, electrical interference from engines and weapons. Their creation weighed 181 pounds and transformed every Sherman tank into a node in the world's first battlefield network, a communication web that would prove more deadly than any weapon system. The BC-604 transmitter generated 25 watts of power, 2.5 times the German Fug 5's output. Operating in the 20 to 27.9 MHz frequency range, it provided 10 preset channels with crystal-controlled stability that held frequency within 0.01% despite combat conditions. The dual BC-603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove decisive in combat, letting them listen to their platoon net and company command net at the same time, maintaining awareness up and down the chain of command. The real revolution lay in frequency modulation itself, Edwin Armstrong's FM technology, licensed to the military, that eliminated the static and interference that plagued amplitude modulation systems. While German tank radios picked up every electrical discharge as crackling noise, every spark plug firing, every motor starting, every piece of electrical equipment, American FM radios delivered clear voice communication even during artillery barrages that overwhelmed German systems with static. November 8, 1942. Operation Torch brought American armor to North Africa, and with it, the SCR-508 radios that would soon demonstrate their crushing superiority over German communications. The 2nd Armored Division's tanks landed near Safi and Fadala with radios that would transform tactical possibilities. The Afrika Korps, despite being the Wehrmacht's most experienced armoured force, battle-hardened veterans who had driven the British back to Egypt, operated under severe communication limitations that no amount of tactical skill could overcome. A standard German tank platoon of 5 vehicles included only 1 or 2 with full Fug, 5 transceivers, capable of both transmitting and receiving. The remaining tanks carried Fug 2 receivers, only they could hear orders but couldn't respond, couldn't report enemy positions, couldn't call for help when ambushed. German tank platoons functioned through rigid hierarchy made necessary by communication poverty. The platoon leader transmitted orders that subordinate tanks acknowledged through actions rather than words, by moving, by firing, by dying. When command tanks were destroyed, easily identified by their multiple antennas, making them priority targets, entire platoons lost coordination, becoming isolated vehicles, fighting separate battles within the same engagement. This vulnerability would prove catastrophic against American forces, where every tank could assume command functions, where loss of a leader didn't mean loss of coordination. The Battle of Kasserine Pass, February 14th to 24th, 1943, provided the first major demonstration of American radio superiority that German intelligence completely failed to understand. Though tactically a German victory, American forces withdrew, Rommel's Afrika Korps demonstrated its tactical mastery. The battle revealed capabilities that stunned Wehrmacht observers who were paying attention. During the confused fighting across broken terrain, scattered elements of the U.S. 1st Armored Division maintained coordination across 50 miles of battlefield. Tank crews who had never met, from different companies thrown together by the chaos of retreat and counterattack, coordinated attacks, warned each other of threats discovered miles away, and called for artillery support through crystal-clear FM communications that worked when they shouldn't have. German signals intelligence units intercepted American transmissions and noted with growing alarm the exceptional clarity and coordination. The 10th Panzer Division's intelligence section reported that American units maintained communication at ranges where German radios produced only static and interference. More disturbing was the realization that every American tank appeared capable of full transmission, not just command vehicles with special equipment, but every tank in every platoon. The German Fug 5 radios, operating on amplitude modulation in the 27 to 33.3 MHz range, suffered from fundamental limitations that no amount of German engineering excellence could overcome, limitations built into the physics of AM technology itself. The 10-watt transmitter struggled to reach 2 to 3 kilometers in ideal conditions, with both tanks stationary, clear line of sight, no interference. In combat conditions, tanks moving, engines running, tracks grinding, range dropped to mere hundreds of meters, often becoming useless exactly when communication mattered most. Every spark plug firing generated a burst of static, every electrical motor created interference, every track movement produced noise. AM systems couldn't filter these signals, turning the electromagnetic spectrum into chaos that drowned out voice communications. September 1943 brought American armor to Italy, where mountainous terrain should have negated radio advantages according to conventional military thinking. Mountains blocked signals, valleys created dead zones, ridgelines separated units visually. Instead, FM technology proved even more valuable in conditions that rendered German AM radios completely useless. The SCR-508's frequency modulation handled the multipath interference of mountain valleys, radio waves bouncing off hillsides, arriving at different times far better than amplitude modulation, which turned echoes into unintelligible noise. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed completely. During the advance toward Kasserine, American armored units demonstrated capabilities that defied German understanding of radio physics. Tank platoons separated by ridgelines, unable to see each other, unable even to see the same battlefield, coordinated attacks with precision that German doctrine said required visual contact or pre-planned movements. The 1st Armored Division's after-action reports described routine coordination at distances where German radios produced only static coordination. German commanders attributed to superior training or rigid adherence to plans, never understanding the technological foundation. June 6, 1944. As Sherman tanks rolled off landing craft at Normandy beaches under German fire, their SCR-508 radios maintained contact with naval fire support ships. Offshore coordination impossible with German technology, unthinkable with their communication limitations. But the hedgerow fighting of Normandy revealed a critical gap in American communications that would have pleased German defenders if they'd understood it. Tank radios operating on 27.9 MHz couldn't communicate with infantry radios operating on different frequencies. The infantry's SCR-300 walkie-talkie operated on 40-48 MHz, incompatible with tank frequencies. This communication gap proved deadly in the bocage, where German infantry with Panzerfausts could approach American tanks through hedgerows, while nearby American infantry, sometimes just meters away on the other side of a hedge, had no way to warn them of danger. American field innovations solved the problem within weeks, demonstrating the adaptive culture that German military rigidity couldn't match. Tank crews mounted EE-8 field telephones in ammunition boxes welded to tank exteriors, wired directly to internal communications. Infantry could pick up the phone and speak directly to the tank commander. By Operation Cobra in late July, this simple modification had revolutionized tank infantry cooperation, creating tactical possibilities German forces never achieved despite years of combat experience. July 25, 33rd, 1944. Operation Cobra demonstrated the full potential of American radio superiority in ways that shattered German defensive plans. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control across dozens of square miles. German defenders from Panzer Lehr Division, once Germany's premier armored formation, an elite unit of experienced veterans, faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by other units miles away, appearing where they shouldn't be, knowing what they shouldn't know. Artillery strikes coordinated through tank radios arrived within minutes of target identification, sometimes before German units even realized they'd been spotted. The contrast with German capabilities was stark and demoralizing. Panzer Lehr, reduced by weeks of attrition and Allied bombing, had been further reduced to communication poverty that tactical skill couldn't overcome. Most tanks operated without radios, depending on visual signals in terrain where visibility rarely exceeded 100 meters through the Norman hedgerows. The few functioning radios suffered from interference and limited range that prevented effective coordination between units fighting just kilometers apart. The irony was profound and tragic for German armored forces. Germany had pioneered radio use in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted on radio equipment in tanks since the 1920 seconds, when most armies still used flags and runners. His book Achtung, Panzer, published in 1937, emphasized communication as essential to armored operations, more important than armor thickness or gun caliber. Guderian had personally developed radio communication systems that enabled tank officers to coordinate attacks with unprecedented speed. He understood that rapid armor advances required reliable communication, that breakthrough exploitation depended on commanders knowing battlefield conditions in real time. Yet by 1943, German tank production couldn't provide the radios Guderian's own doctrine demanded. His principles were proven correct. but Germany lacked the industrial capacity to implement them while also building tanks, while also fighting on multiple fronts, while also replacing losses that exceeded production. German production statistics revealed the crisis in brutal numbers. In 1943, Germany manufactured approximately 5,700 medium tanks, Panthers and Panzer IVs, rolling off assembly lines at rates that seemed impressive until compared with American production. But fewer than 2,000 Fug transceivers were produced. Many radios went to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment, forcing platoon leaders to rely on visual signals that enemy fire could disrupt. Soviet tank forces suffered even worse communication poverty that made German shortages look mild by comparison. The T-34, despite being the most produced Allied tank with over 84,000 built during the war, typically entered combat without any radio equipment at all. Soviet doctrine relied on flag signals and pre-battle planning, rigid adherence to plans that couldn't adapt to battlefield chaos, with catastrophic results against German forces in 1941, when flexibility mattered more than numbers. By 1943, Lend-Lease provided some relief. American radios, including SCR-508 sets, equipped Soviet command tanks, bringing American technology to the Eastern Front. But even by war's end, only about 25% of Soviet tanks carried radios of any kind. The comparison highlighted American achievement. While the Soviet Union struggled to equip 1/4 of their tanks with any radios, America achieved 100% deployment of sophisticated FM systems, every tank, every crew, connected. Motorola's Chicago factory represented American industrial mobilization at its peak. Civilian industry transformed for war production. Before Pearl Harbor, the company manufactured car radios for civilians. Converting to military production required complete retooling and solving unprecedented technical challenges. Mass-producing precision electronics that had to work in conditions engineers called impossible. Each SCR-508 required 2,748 individual components manufactured to exacting standards that allowed no variance. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability despite temperature extremes from -40 degrees Fahrenheit to 125 degrees Fahrenheit and combat vibration that could shake loose, poorly soldered connections. Production statistics told the story of American industrial might. 1,942, 3,800 SCR-508 family radios, 1,943, 11,400 units, 1,944, 24,000 units, total wartime production, over 50,000 tank radio sets. This production miracle ensured that all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment, an achievement no other nation approached, that no other industrial base could match. The SCR-508's advantages went far beyond simple frequency modulation, encompassing engineering details that multiplied effectiveness. Crystal-controlled frequency stability meant tanks could preset channels before battle and maintain perfect alignment, despite combat conditions. German Fug 5 radios using variable capacitor tuning constantly drifted off frequency, requiring constant manual adjustment that distracted commanders during combat. The dual receiver configuration allowed commanders to monitor their platoon net and company command net simultaneously. Orders flowed down the chain of command instantly, while commanders maintained awareness of subordinate situations, creating bidirectional information flow German systems couldn't match. The BC-606 intercom system integrated seamlessly with the radio, allowing all 5 crew members to alert the commander to threats instantly. Throat microphones and noise-cancelling headphones enabled clear communication even during combat when conventional microphones picked up only engine roar. Many German tanks lacked intercoms entirely, forcing crews to communicate by touch signals or shouting over engine noise. Commanders literally couldn't hear their own crew reporting threats. Power management provided another American advantage invisible to German observers but critical to performance. The SCR-508 operated on either 12 or 24 volts, automatically adjusting to available power from whatever electrical system the tank provided. The dynamotor power supply provided stable, filtered power that eliminated electrical interference at its source. German radios powered directly from vehicle electrical systems picked up every spark, every voltage fluctuation, every electrical transient as static that overwhelmed voice communications. The tactical advantages of universal radio deployment transformed American armored doctrine in ways German commanders never fully grasped. The combat command structure flexible task forces organized for specific missions rather than rigid permanent formations depended entirely on reliable communications that German forces didn't possess. American commanders could create ad hoc battle groups from different units, mixing tanks from one battalion with infantry from another, adding tank destroyers and artillery as needed, confident they could coordinate through compatible radios. This organizational flexibility baffled German commanders accustomed to rigid structures necessitated by limited communications units, had to train together because they couldn't coordinate with strangers. During the Battle of Aracourt in September 1944, the 4th Armored Division faced multiple German Panzer brigades equipped with superior Panther tanks that outgunned and out-armored Shermans. The Germans had every advantage in armor thickness and firepower on paper. They should have won decisively. But American radio coordination proved more decisive than technical specifications. Every Sherman could report enemy positions instantly. The network saw everything anyone saw. Tank destroyers received targeting information from tanks they couldn't see, positioning themselves perfectly for ambush. Artillery observers in Sherman command tanks called in devastating barrages within minutes of identifying targets. Over 3 weeks of intense fighting, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 kill ratio that defied technical specifications that made German tank superiority irrelevant. Throughout the war, German intelligence failed catastrophically to grasp the significance of American communication superiority. Combat reports mentioned American coordination, noted their ability to concentrate forces quickly, observed their tactical flexibility, but they attributed everything to training rather than technology, to doctrine rather than radios. A captured September 1944 intelligence assessment stated with confidence, American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures. The report completely missed the technological advantage, never understanding that American tanks possessed capabilities German systems fundamentally couldn't match. German tactics never adapted to American capabilities because they never understood them. They continued targeting supposed command tanks based on antenna configurations. Multiple antennas meant command vehicle in German doctrine, not realizing every Sherman could coordinate battlefield responses. They planned ambushes, assuming American tanks would lose coordination when separated standard German experience with their own limited radios, not understanding that radio contact maintained unit cohesion regardless of visual contact. They expected American forces to pause and consolidate what German forces had to do when communications failed, never comprehending that Americans could maintain operational tempo precisely because their communications never failed. March 1945. As American forces approached the Rhine, their communication superiority reached its zenith in one of the war's most dramatic moments. The capture of the Remagen Bridge demonstrated the speed of American command and control enabled by universal radio deployment. When the 9th Armored Division discovered the Ludendorff Bridge, intact bridges were supposed to be destroyed. This was a miracle, or German failure radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the entire front were shifting to exploit the opportunity, redirecting from planned operations to reinforcing the bridgehead. German forces, dependent on telephone lines that American aircraft had systematically destroyed, couldn't respond with comparable speed. American radio coordination created an impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating fires through radio networks. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed in detail. April 1945. The encirclement of the Ruhr pocket demonstrated the culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications. Two separate army groups executing precise maneuvers across hundreds of miles of front. Inside the pocket, 325,000 German troops found themselves trapped, partly because their communications had collapsed completely. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes, telephone exchanges, radio stations, command posts. Wehrmacht units lost contact with higher headquarters and with each other, fighting isolated battles within the larger encirclement. Field Marshal Walter Model's final messages before communication failure revealed the German plight. No contact with adjacent units. No communication with higher headquarters. Fighting continues, but coordination impossible. American radio superiority profoundly affected the psychological experience of tank warfare in ways that don't appear in after-action reports. American crews fought with the knowledge they were never alone, even when physically isolated. Behind enemy lines, they remained connected through radio waves, able to call for help, able to warn others, able to coordinate. German tank crews experienced the opposite: profound isolation. Unable to communicate, they fought individual battles within larger engagements, never knowing if help was coming. Unable to warn others of threats they discovered. Otto Karius, one of Germany's most successful tank commanders with 150-plus kills, wrote in his memoir Tigers in the Mud about the challenges of limited communications. Though he focused more on tactical aspects than the communication gap itself, perhaps not fully realizing how much worse German systems were compared to American networks. The strategic implications extended far beyond individual battles. American advances in 1944–45 maintained operational tempo, partly through radio coordination that German forces couldn't match. The Third Army's race across France, Patton's famous advance, depended on radio networks that maintained control across hundreds of miles. German commanders consistently underestimated American capabilities because they couldn't conceive of the communication superiority. Americans possessed it was outside their experience, beyond their understanding. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the problem but couldn't solve it. In a December 1944 memorandum to Hitler's headquarters, he acknowledged that American coordination was negating German advantages in tank quality. After Germany's surrender, American technical intelligence teams evaluated captured German equipment with systematic thoroughness. Their findings confirmed what combat experience had suggested. German tanks often possessed superior armor and armament, but catastrophically inferior communications. U.S. Army Technical Intelligence Report, number 176, concluded, German tank communications equipment was approximately 5 years behind American systems in development. The absence of frequency modulation, limited radio distribution, and poor electrical noise suppression created critical tactical vulnerabilities. Soviet evaluators reached similar conclusions. The Red Army, given access to captured German equipment, chose to copy American radio designs rather than German systems for post-war tank development. Production and deployment statistics reveal the magnitude of American achievement. American radio production. SCR-508 divided by 528 divided by 538 radios produced, 50,000 plus units. Sherman tanks produced, 49,324 units. Radio deployment rate, 100%. Transmission power, 25 watts. Frequency stability. Crystal controlled, plus or minus 0.01%. Range, moving, 7 miles. Range, stationary, 10 to 15 miles. German radio production. Fug, 5 transceivers produced, 6,000 units. Medium divided by heavy tanks produced, to 12,000 units. Full transceiver deployment rate, 20%. Transmission power, 10 watts. Frequency stability, variable plus or minus 1%. Range moving, 0.5 to 1 mile. Range stationary, 2 to 3 miles. Communication effectiveness, average time for American fire mission, 3 to 5 minutes. Average time for German fire mission, 15 to 30 minutes. American tanks achieving coordination, 100%. German tanks with full communication, 20%. The radio superiority of Sherman tanks established principles that govern armored warfare today. Modern main battle tanks carry communication suites that trace their lineage directly to the SCR-508 digital rather than analog, encrypted rather than clear voice, but fundamentally based on the same principle: universal deployment and reliable coordination. The German Bundeswehr, rebuilt in the 1950 seconds, prioritized communications based on World War II lessons painfully learned. Every Leopard tank manufactured has carried comprehensive radio systems. A Bundeswehr training manual explicitly states, "The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority." Modern conflicts validate this lesson repeatedly. In the 1991 Gulf War, coalition forces with superior communications destroyed Iraqi forces, equipped with individually superior Soviet-designed tanks but inferior radios, and no network integration. In 2003, American forces again demonstrated that network-centric warfare defeats platform-centric warfare that connected adequate systems, defeat isolated superior systems. The story of American Sherman tank radio superiority represents a victory in the electromagnetic spectrum that proved more decisive than advantages in armor or firepower. German tank crews fought their war partially blind to this revolution, discovering too late that every Sherman tank was not just a fighting vehicle, but a node in history's first battlefield network. The SCR-508 radio transformed the M4 Sherman from an adequate medium tank into a component of a weapons system that included every other American tank on the battlefield. This transformation proved more decisive than any improvement in armor or firepower could have achieved. Every Sherman tank carried the tools of victory not just in its 75mm gun or sloped armor, but in the 181 pounds of radio equipment that connected its crew to every other American tank crew, creating a collective intelligence that no individual German tank, regardless of superiority in armor or firepower, could match. German forces discovered this reality through bitter experience at Kasserine Pass, in Italy's mountains, across France's hedgerows, and in Germany's final battles. American tanks demonstrated coordination that German doctrine said was impossible without visual contact. The Wehrmacht never developed an effective counter because they never fully understood the technological gap until it was far too late. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender: "We knew how to build better tanks, but you knew how to make them work together," captured a fundamental truth, whether accurately quoted or apocryphal. America had built not just 49,324 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network. The revolution in military affairs that historians identify with modern network-centric warfare actually began in 1942, when the first Sherman tank with an SCR-508 radio entered combat. From that moment, warfare changed forever. The side with superior communications would defeat the side with superior weapons. The network would defeat the platform, and the connected would overcome the isolated.